Hello YouTubers. This is the second video in our series about the standard, the engineering standard, which is basically a collection of coding guidelines, team practices, high-level architecture and low-level architecture practices that basically helps guide the development of any system. Specifically the low-level architecture series, which is what this video is about. It helps you design a system in general, regardless of what this system is. It could be a front-end, back-end, it could be a mobile application or a desktop application. It could even be a watch app or whatever you're building or a back-end service. It doesn't matter. These architecture patterns, the beauty about them is that they're not bound by technology and they're not bound by a platform and they're not really bound by a particular programming language or framework or whatever the case may be. Technology in general. Um, uh, in order for you to just see the right picture here, the first and most important thing that you want to think about when it comes to implementing the system is abstraction. How to protect your system. You already figured what your system is supposed to do. Let it be a calculator or a commercial website that sells products like Amazon or whatever your system may be, regardless really what it's trying to do. You already figured out what your core business logic is supposed to be. And a good design is a design that allows you to kind of componentize your system to make it configurable and pluggable. So as technology changes and as particular frameworks change and patterns change, somehow you need to keep your business logic in this little bubble and plug in new technologies in and out of it, right? So you can expose it however you want to do and plug in technology in and out of it, however you want to make sure that your business logic is maintained in a good state, and then everything else is just a little shell around that. To give you just a little bit of a high-level picture here, assume that this is your business logic right here, right? This is what makes your application different than anything else out there. So, for instance, in a schooling system, having the students and the teachers and the, exams and all of that kind of stuff, that's really the business logic, right? And then around that business logic, there is the level of abstraction, which is I want to be able to send emails. I want to be able to, so this here is external resources, right? So these are resources that your business logic needs to interact with in order for it to be, able to communicate with external systems. And this piece is really, really important. Whether your external resource could be a database, it could be an email service, it could be an SMS text messaging service, it could be whatever it may be, maybe a geolocation API that you're calling to pull in cities and states and names of streets and towns and whatever the case may be. You have to think about this really clearly when it comes to designing your system, in the sense that you want to keep your business logic as abstract as possible away from that external resources situation. What that basically means is that, if I am developing a system that relies on a storage technology, let's visualize this. Let's say I have in here a schooling system in here. This here is my schooling system. And my schooling system needs to store its data somewhere, right? So let's say at some point in time we had Microsoft SQL Server, to be the point of communication between that schooling system. The rule here is, this is your the way you can examine a system is basically when you go and say, I should be able to change from SQL to Cosmos or NoSQL or MySQL without changing one line of code in my business logic. Okay, there might be changes in the little thin layer outside of that, but no changes into that business logic. If you're changing an external technology and it requires you to change implementation in your core business logic, which what we call as processing services, orchestration services, coordination services, management services, and aggregation services. If you have to change any of these categories of services that live within your system, and we're going to talk about that in a second, don't worry if you don't know what processing, orchestration, and all of that stuff means. It's not a big deal. You want to say, I should be able to change the technology without having to change my core business logic, which means it basically begs the question of, where do you draw the boundaries of a system, right? The boundaries that basically ensure that, beyond a particular point and a particular code base or particular service, you may not use particular models or particular technologies or whatever the case may be. Okay, this is the theory. The theory is great, but how do you bring that into reality? Like, just the fact that I told you about this, I already told you about the idea of separation of concern. I already told you about the idea of dependency injection, dependency inversion. There's a bunch of solid principles are all baked into this. But in order to bring this into something useful that actually can materialize itself into a product that you can go out there and sell it to someone, you have to actually kind of work with concrete examples. Let's still conceptually talk about a little something. What we call in any system that you build, so this is the system. I want you to really burn that picture in your mind and your memory to remember that, you want to abstract the system. You want to make sure that your system is abstract, but at the same time, you want to make sure that you keep your business logic away from that particular external dependency. How does that look like really in reality? There is this thing that we call this external resources is basically two different layers in and of itself, and I'll tell you right now what that means. In the external resource realm, let's just assume that you have a bunch of processing services in here, services that handle your business logic and services that handle, and I'm intentionally giving it different shapes. Like, even though I'm going to give it a different color, I'm still giving it a different shape. So let's say you have business logic in here that basically works like this. So let's say you have an API, it's just a simple API. And that simple API is basically requiring you, so this is a simple API here, and that API is requiring you to be able to register a student and create a student card, library card for them, right? So you have something called, so this is a student storage broker, and I'll tell you in a second what that is. And there is library card storage broker. And then in here you have student service. This is a foundation service, and we're going to talk about that as well. And then you have library card. This is all within your API. They're just classes, right? And then in here you have a student processing service. And this is library card processing service. And this here called student orchestration service, and we're going to talk about all of these in a second. Orchestration service. Okay. So what's the boundaries in here? The boundaries here are a little different. Remember that picture that we draw up here? Let's take this guy up here, and let's get rid of this schooling system example. And let's go down here and let's talk about where does this fit. So these are basically, simple systems. Let's increase the size of this guy so it's a little bit more visible what we're trying to accomplish. Okay. So I'm going to take away the colors from this guy. You know that this is business logic and this is the boundary. And I'm going to take away this guy like this. And I'm going to go ahead in here and move this guy down like this. Now watch what I'm doing. And in here, I'm going to extend this guy like this. Now we need a better box. Throw that guy away. Bring out this guy. Like this. I'm going to send this to the back. All right. What's really going on here? What's happening is that when we talk about abstraction of any kind, it's kind of it's not a cut and dry kind of concept, especially when it comes to, letting go of particular outputs and particular logic that is really dependent on the external dependency than anything else. For instance, let's say this storage broker talks to a SQL server in here. And this library card could be talking to an API. There's already an external system that is completely unrelated to this, and this is just an API that it's talking to. And this guy here is a SQL server, like this. The first point of contact when it comes to working with brokers is to be able to add a very thin layer. That thin layer may not have sequence, it may not have iteration, and it may not have selection. Basically, you can't have if statements in it. You can't have if statements including try catch, case statements, switch case, because all of these things are technically business logic components that need to be test driven. It can't be changed. It can't be written without an actual test examining all the different scenarios. So we keep these brokers as thin as possible, meaning that you just build a contract, an interface, and this contract wraps up the existing SDK or API call that works with that system. What does that look like in the real world? There's this really amazing application that is open source, and I really highly encourage you to take a look at the source code that will help you see things how they look like in a real world application. So we have this system called OSSS, Open Schooling System, Open Source Schooling System. And this open source schooling system, let me fix the fonts here real quick so you can see the picture here a little bit clearer. Here we go. All right. So check this out. If you look at any schooling system, or a good system that follows a particular standard, you will notice here that you have this brokers area. In this brokers area, you have this thing called iStorageBroker, which basically describes the contract that your foundation service is going to be working with. This contract is basically your ability, and this contract literally what enables you to switch implementation underneath without having to change much from a functionality and test standpoint. Not change much. You will still change few things, but not change much at the foundation level. What that basically means, let's say we have a simple storage broker like fees, for instance, like exam fees and all that kind of stuff. You go and build a partial class, an iStorage broker that has these bunch of methods. And these methods normally they use the language of the technology they're speaking with. So basically, they're using, if it's a storage, I have globally basically decided that whatever storage you're communicating with, it may as well have the language of storage like insert, select, update, delete, language that's very specific to storage since the beginning of time when it comes to storage. Like in a SQL statement, you say select all from students. So you're saying select all fees, select fee by ID. The language here is really important because the language is it's what's going to help your cognitive resources later look at something and know exactly where this is coming from, in addition to the naming convention. Of course, it should be saying storage broker or student storage broker, wherever the case may be. But still, the language, it's like DNA. The language in every method that you're using in your storage broker should be reflective of the kind of operation or the category of concern that's actually working with. So what that basically means is that underneath this guy, I just so happen to use SQL Server through the Entity Framework. But I could actually, in the fees example in here, I could literally switch that implementation in here and switch from using Entity Framework for SQL. I can switch to using Entity Framework for Cosmos, or use a completely different technology that communicates with storage accordingly, right? You could be Dapper, it could be whatever you want to use it, right? Although that, recently I had this amazing discussion with a gentleman who was kind of still trying to digest that concept with using Dapper and all that kind of stuff. And Dapper is for people who want to write C# and SQL at the same time. Don't have something really big against it, but I prefer that the purity of the language that you're looking. So it's a lot easier for me to go and say, okay, this is all C# than going in the middle here and saying, oh, I'm going to write some SQL in the middle of my C#. But that's a discussion for another day. The purity of logic, and I could be super wrong about this, but I strongly recommend keeping the language and keeping the overall theme of the code that you're writing consistent and coherent, right? There's a big reason I don't even use the out-of-the-box SQL-like link expressions, right? Like when people go and say select S here, fees. Some people go and do this from fee select. See, you're writing kind of SQL, right? I don't vote for that. I don't like that because it looks a lot like a SQL statement than a C# statement. So I stay with this fluent API, fluent, kind of expression when it comes to writing SQL statements or actually interacting with some storage of any kind. So let's go back to our topic here. So you see how the implementation of insert fee async is living under this contract, and your student service that actually communicates with this guy, this student service in here, it actually interacts with the contract, not necessarily the concrete example. What that basically means is that when register student async goes and says insert student async, it doesn't know which kind of implementation lies underneath that. And that's the beauty of dependency injection, is that you can go and say, I subscribe to a particular contract, but whatever implements that contract, I don't care. That's a huge level of abstraction. If we go back to the Blackboard in here real quick, what that basically means is that since my student service, let's say this is your student service, is actually dependent on a contract, and this contract could be, so this student service is dependent on iStorageBroker, right? Whatever lives behind that iStorageBroker doesn't matter. It could be a SQL broker, it could be a NoSQL broker, it could be literally a bunch of files on a system. It doesn't matter as long as these services or these brokers adhere to these contracts. So actually the line is going from here to here. So this implementation like this, see, you could have as many implementations as you want, right? You could have like SQL storage broker. You could have here Cosmos storage broker, right? Or you could have just simply something like in here, something like a files storage broker. You're just storing everything in a file, right? And you're communicating accordingly, right? What's happening in here? What's basically happening is that you're basically saying my service in here will get to choose to communicate with this, and then whatever configuration you have will route the information there. That means that my business logic, my partial business logic of persistence, isn't really impacted by the technology. If I go today and I say I don't want to use SQL anymore and I want to use Cosmos, there is no problem. You will not be changing too much in here. And I'm saying too much, right? There's few things that are still going to change, but that's a discussion for another day. What I really want you to get out of this video is that these brokers, when you build them with a contract, they basically give you the ability to switch the technology behind the scene without having to impact the core business logic of your system, right? In other words, if I go back in here, your student service is communicating with a student storage broker and a library card broker. It doesn't really matter, because once you get into the portion of your code that is normalizing this and turning it into local models and local methods and local functionality, it won't really matter what kind of technology you have in here and what kind of models are dealing with in here, which is another topic when we come to talk about foundation services. Okay, so we need brokers, and these brokers can be for anything, right? They're not specific to storage. They're not specific to any service. It's just the concept of abstraction. Some people call it clients, right? And you will hear some people call it adapters, like the folks, brothers and sisters that work with the Java technology or Java-like technologies, they will say adapters, right? If you're working with JavaScript and stuff like that, they'll call it dependencies and maybe, inject components and stuff like that, whatever they're doing in there, right? What I'm trying to say is that just from a design standpoint, regardless what technology you're using, you want to always have this kind of component that wraps up the actual literal implementation from an external library, right? So it's an external library. So if we go back in here, the wrapper that's happening in here, so if you look at the student student storage broker implementation in here, in the actual implementation, there is something called find async. This is a foreign language to your application and should not seep into your business logic, right? So when you the language that you chose to have for your system is select student by ID. But what's coming out of the SDK, this find async in here and this student thing in here is basically a not something that you've implemented. If you go like this, it'll say, oh, this is an implementation of the Entity Framework. What that basically means is that, let's say the folks that implement the Entity Framework came today and they say, well, we're not going to call it find async anymore. We're going to go and say, search async. Let's say they just changed that language all of a sudden. They changed it on you. That means that your business logic, at least the first level of abstraction, will not change. Why is that? Why it's not going to change? Because it doesn't matter this change in the technology here, because you're still going to have to adhere to select student by ID. So the only thing that's really going to change is your brokers, and it will stay there. And you will not have to change anything moving onwards, right? So if you go into, and that basically gives power and flexibility to your application to give it the kind of ability to be able to adhere to newer technology and adhere to newer patterns, right, as people shift implementations behind the scene without having your business logic be impacted. All right. One of the most common things that people say to me is that, what about the exceptions? We need to handle the exceptions in here. Nope, you don't really need to handle the exceptions here. That's why you have the second layer or the last layer of abstraction, which is the foundation services, which we will also talk about in this series. Let's talk a little bit about the language of brokers, right? So we talked a little bit about how it's using SQL-like, storage-like kind of language, like select, insert, delete and update and stuff like that. It's really, really important, and this is probably a bad thing. Like in here, you need to have your namespace for your brokers, and this is general for everything. Like you see date times, loggings. If you're building a folder, that's a namespace. And if you're building the namespace, you want to basically make sure that it's plural. Because a namespace, a folder, is meant by default, it may not, but it's meant to have many, many things under it. It's not always the case, but it's meant to be. And if that's the case that it's meant to be, then it has to be in a plural state. So you're saying storages, right? You're saying loggings. You already said brokers. What's under brokers? Storages, and here's my storage broker, right? So you want that naming convention, and we also want to make sure that when you change the folder, today in Visual Studio, we don't really have the technology yet, but hopefully maybe a suggestion someone is going to put in there. Maybe I'll do it myself. You want to go in there and basically say, I want to be able to, make sure that my namespace as well is in the right place, right? So this is all your namespace right here. And that basically you want to make sure that all these namespaces, so brokers, storage, how do you change that real quick? You go like this, and you go like this, and you find broker storage, and we change it to broker storages like this. There you go. There will be one error in the original file that we changed, and that's okay. But after that, everything else should be just fine. Did I change the current document? Yeah, we should probably change this for the entire solutions. This is broker storage. Change it to broker storages, and it's going to change probably a lot because this is a real life application, right? This is the whole thing, right? So brokers, storages. This is good. Huh. Control Shift F. Find and replace. Replace it to controller storages. Entire solution. This probably is going to change a lot. There we go. Yeah, it's a huge solution, so it's going to take a while. But anyway, The point that I'm trying to make is that, you want to have your storages, your whatever your broker is. It could be, an API, if a geolocation API. So you're going to say geolocation APIs. And you also want the language to be as generic as possible. So you're not really saying SQL broker for the namespace specifically. No, you're saying something more like storage broker, user broker, 166 occurrences. Wow, that's a lot. Okay, anyway, so that's everything, right? So you want to make sure that these changes, yeah, that one guy is going to be like this, and then, yeah, there you go. So namespaces, storages, you want to make it this way. But also you want to make sure that it's generic. So it's plural and generic. Plural value and generic. So for logging, for instance, you don't go say app insights logging. You don't say that. You don't say system date time offset. You say date times, right? The same thing happens in here. This should be user managements or users when you're communicating with a particular API or an identity, a local identity authority, or whatever the case may be. You want it to be as plural as possible. The other thing here about having your brokers is basically, you know that your brokers will always be the first point of contact, but not the only point of contact. No exception handling. The second most important thing is that every broker, whatever that broker is, should handle its own configurations, right? So you don't leave that configurations anywhere else except at the broker itself. You know what I mean? So basically, a lot of people would take this and put it in Startup CS. So it's a completely different file all the way over there. Let me revert these changes real quick just so, I don't have to distract you with the errors. And then I'll do a code rub later. And if you don't know what code rub is, I will talk about it in another session. But, I see a lot of people go and configure their storage in the Startup CS itself. Don't do that, because that basically means you have scattered concerns across your applications. Don't go into a Startup CS in here, for instance, and go say, oh, I'm going to set up my storage broker. You'll see people do this in here. They'll go and say, this is for my context. These are my options, like this. Options.useSQL or something like that, or use internal provider or whatever. And they go and say options. Here's your context. Right. And if you say use SQL like this, I think it's looking for use SQL Server like this. And I think it's looking, yeah, there you go. Use SQL Server. Don't do that. I see a lot of people do that, and it's really, really bad. It's bad because when you say use SQL Server and you're configuring it, that means your logic is scattered all over the place, which is really, really bad, right? It means that if you pluck out your storage broker and you change it with a different implementation, you have to change code in two different places. That's really a code smell. That basically means you don't have the right level of abstraction, that's going on there. Okay. Now, the other thing, we talked a little bit about the language, one other important thing about brokers is that they can't call each other. You can't have a broker going into here and you can't say, okay, it uses the configuration. You can't also go ahead in here and say iDateTime broker like this. They can't call each other. The flow, and you're going to see this across the entire application. You're building a monolithic application with a microservices mindset, which basically means that the component that you're building is always going in a horizontal flow. They don't talk to each other like that. Even when they need to talk to each other, you build another one where they both connect. If I go back into my the Blackboard in here real quick, you will notice this flow. Look at the flow. Look how the flow is going horizontally. The flow is going horizontally basically, which means that your application, you can't have a broker talk to a broker like this, because that creates a dependency that you don't need to have, right? That dependency will make your application literally spaghetti code. The literal implementation of spaghetti code, when you have systems like these, or you have a foundation service talking to two entity brokers like this, that's really, really bad. Because that basically means that your brokers are not atomic and individual components anymore. They are dependent and intertwined, and this intertwined state is basically the source of all evil in most of the bigger applications, because now there is no rhyme or reason to how the communication is happening. When you want two brokers, two entity brokers, and we're going to talk about the types in a little bit. When you want two entity brokers to talk to each other, you want to build services on top of them, and then you want to have an orchestration service like this one connect both of them. This is important because if you don't do that, what basically happens is that there is no limit for the amount of dependencies that you're going to have when we got to talk about the Florence pattern later and what actually governs this. But what this basically means is that your classes are intertwined and your services are intertwined too much that they have to know about each other. In order for us to have classes know about each other, you need a third class to introduce them to each other. It's like, if you have a friend of a friend and they want to introduce you to each other, right? You have to have that middle guy or girl to actually introduce you to each other. This ensures that each one of these have single responsibility and single concern, but they're also atomic components. You lose that level of individuality for each and every component as you go forward into the business logic. But you still know that a particular orchestration service or coordination service is doing that as one single responsibility to basically delegate the work, right? Some of the implementation about single responsibility is when you go and say, every class should either do the work or delegate the work, but not both. You can't do the work and delegate the work at the same time. For instance, if this student orchestration service is trying to create a student and create a library card for it, it should not do either one of those. It should delegate both of those to other classes, and when the results come back, it'll do its own work and move on. Some people might take this concept to extremes, so they would say, I only want a single point of contact to do the combination or orchestration, meaning that I want to combine two entities together and provide an API that provide that information. And then later on, I will use that information to actually do some processing on top of it. Sure, you could do that stuff. What we basically do is that we'll leave the business logic in the orchestration while it's combining this. Maybe in another release, in another version of the standard, we might explore that option. What else about brokers that I want to talk to you about today? So we talked about, how you break it apart and all that. When you're designing a broker, if your broker is handling multiple entities, it's really, really useful that you go and say, I'm going to leverage a partial classes. And partial classes are not always a thing in other programming languages. It's very, very specific to C#, right? C# does partial classes. I don't know what other languages out there that can support partial classes, but as far as I know, it's very, very specific to C#. There could be other entities and other languages out there that do the same thing. Let's take a quick look at what that looks like. So if I go back into my code here, you will notice something interesting. You have a storage broker, which is a partial class, right? This is a partial class of a storage broker. But at the same time, every time I need a new entity, I break it apart into its own file. So I know that when I'm going into this file, right, I say storage broker dot assignment, storage broker dot attachment, storage broker dot attendances, and you want to make sure that it's in plural formats. You're saying classrooms, contacts, students, and courses, and all that kind of stuff. That basically tells you that this one file, see, we already categorized brokers, right? But it tells you this one particular file is concerned with that. Some people suggested that I use the repository pattern, so I don't have to create each one of these files. But that's not practical because you don't always need all CRUD operations, and sometimes you need additional CRUD operations. So if you have to subscribe to an interface, an iRepository interface, you have to implement all of these CRUD operations that you don't really need. Why would you implement something you don't need, right? Sometimes you have to delete all, sometimes you have to update all, sometimes you have to do all these kind of different things. Why would you need to do something like that? Okay, so let's go ahead in here. Let me clean up some things in here. You just build my solution because this erroring thing is getting a little bit frustrating. I don't want you to see erroring stuff. Here we go. All right. All right. So everywhere you jump into a particular service, you see that it has its own little implementations to a specific need, right? So brokers also reflect the need. Of course, in general, they offer CRUD operations, but more often than ever, you want to do a delete all, you want to do an update all, which is not something you don't always use at the same time. You will notice that when I talked about brokers, there are two different types of brokers. There are entity brokers, brokers that are actually fundamental to your business logic. They help you go pull data from a particular resource. They help you go and persist data and all that kind of stuff. And there's utility brokers. Utility brokers are like date times. You need to pull in the date time. You need to, log something. You need to any kind of these things that are not crucial to the business. Like, for instance, if you pull out the logging out of your business logic, nothing is going to happen. Your system is still working. It's just that you hurt the monitoring aspect of your business logic. If you replace, datetime brokers with, system.datetime, it's not really going to hurt your business logic, right? It may make your code less efficient and less pluggable and configurable, but it doesn't really hurt your business logic. So utility brokers is something you can use across the system, but your entity brokers are brokers that you have to use as a point of abstraction, and you have to build a foundation service on top of it. And we're going to talk a little bit about foundation services, but that's basically, like you can see in here in the datetime broker, you're basically just abstracting away the way you get a datetime, so you can test drive, you can stop time and see how your service operates when you mock that datetime broker, and you determine, what needs to happen with a particular implementation. The same thing happens with logging. Logging here is have log information, trace, debug warnings, error, and critical. It could use whatever implementation underneath, but it's basically helping you. It's utility. It's basically helping you, implement better application, but they don't necessarily, like, you can find them in any system. Like, I've built so many different applications, over 32 applications right now running in production, throughout the course of my 21-year career, and logging and date time never change, right? So it's not something specific to your application. That's what we call utility, right? It's just a utility. It helps you. You can inject it anywhere. It's like these commons. People used to, back in the old days, they used to say we have a commons library and it has all these helpful functions, but they were not written in a way that is test driven and is easy to understand. Okay, we talked about the implementation, talked about the brokers, we talked about what it looks like. Here's some, some common questions that people say. Is brokers like the repository pattern? It's kind of. Repository pattern, however, forces you to implement a particular functionality that you don't necessarily need. Brokers will give you that kind of flexibility, to implement only the stuff that you really need from a CRUD operations or more, right? Brokers are not supposed to be mappers. They're not supposed to be mapping things for you. And we're using partial classes because we're working really hard on the, engineering experience. We want your engineering experience to be better than we don't want you just to implement software, because demoing software or delivering software is just about 15 minutes. Maybe your demo is a little bit longer, so it's 1 hour, right? But the majority of your time as an engineer is actually spent into writing the code and implementing the features. So it's really, really important that you invest your time and effort into the engineering process itself, to make sure that it's enjoyable, and then let the demo and the delivery and the success and all that kind of stuff come in as a side effect of following better patterns and better implementations and better mechanisms. In general, and let's go back in here, I just want you to remember this. Brokers' main responsibility is to wrap up, it's usually 1 or 2 lines. They don't have if statements, they don't have while loops, they don't have try catch in them. It's not the job of that broker to do. It's basically normalizing the language to adhere to a particular contract for your foundation services. So if the language and the version changes on you, or the technology changes on you, your foundation services are not impacted. Your foundation services will be impacted with other things. This is why it's in the middle between the level of abstractions. This is the abstraction realm. and this here, your core logic realm. So this is here external abstraction, external resources abstraction that happens in here. But your business logic, this is your core logic in here, or core implementation in here, doesn't really get impacted by that change of language and that change of implementation, as long as you adhere to these particular contracts. So this is basically just an introduction to brokers. I still have to walk you through actually building a broker, and showing you how that looks like when you try to build a broker. What's it look like from an implementation standpoint? When do you decide to wrap a broker, and when do you decide not to wrap a particular external resource in broker? Almost always you will need to, but there are some edge cases that we will talk about hopefully in other series, in other videos in this series. Just remember, the standard in general is meant to make your life easier as an engineer, right? It helps you think about the possibilities of what your application can accomplish. It makes your system more solid and more able to bear changes in the tech industry. Because think about your application as a fort. You're building a fort. You're trying to protect your application, and then everything around you is changing almost all the time, right? And because these things, and you can't trust these things, just because you have it, the more dependencies you take on, the more likely that your SLA, your uptime is going to be impacted by that. And this is why the idea of microservices is really great, because you're basically limiting the failure, the single point of failures and dependencies based on particular domains and particular business boundaries, right? That basically handles these particular operations, right? So for instance, if you have a dependency on an SMS service, and the SMS service just so happens to be in the pipeline of registering a student. So when a student registers, you send them an SMS message or an email message. You keep that away in case the SMS service is down. It doesn't block your existing process. That's the beauty of microservices. You're abstracting the responsibilities, and you're dividing these responsibilities apart, so you can actually look at your system and be able to let the critical operations happen, and let the least critical operations go into a retry logic or a trial and error kind of situation. The stuff that I'm teaching you in here are not meant to be the same forever. They change all the time. The more we learn about brokers, the more we learn about abstraction, the more we take these solid principles and take these ideas that are out there and bring them into a particular flavor and a particular interpretation. The idea about brokers and breaking them in this case is my personal interpretation of abstraction, right? The separation of concern, right? It's a personal interpretation, meaning that there might be many other interpretations out there, and you need to pick and choose and see the one that makes more sense to you. In the description of this video, I'm gonna leave a link to particularly the brokers chapter in the engineering standard, and I highly recommend that you follow that repo, because I try to update it frequently. There's major changes that are coming to that standard, and I really highly recommend that you take a look at it. But also as an engineer, whether you are at the beginning, mid, or advanced level in your career, just take a look and participate in the open source schooling systems OSSS, so you can see what that level of abstraction actually looks like in the real world. Last but not least, because the standard changes all the time, and because these things changes all the time, I am always open for suggestions. My engineering standard is used in so many different places. I use it on my day-to-day job. I use it in my open source projects. I use it in my private projects. I use it everywhere. And because I use it everywhere and I work with so many different people, it actually helps me get feedback from people to see where we can improve it and where we can leverage a particular ideas, right? And these frequently asked questions section is specifically because of people that reach out to me and ask me questions like these. You'll also see a lot of discussions, around OSSS as a project. So if you go in OSSS, you'll see so many different discussions. This is, technically, if you look in the issues area, you'll see a lot of discussions that are going around the standard, people trying to ask questions. You'll see here the exact same, view that I was just presenting to you in a second. And you'll see different people asking, having concerns and having different questions. They come from different schools of thought. Take a look and learn, right? And contribute to these projects, because your contribution to open source projects, especially when it feeds in projects that are actually working towards the making the world a better place, ensuring the survival, the evolution of the human beings and our survival. It's really important that you take a part in this as an engineer, because you have a skill set that's very, very rare, and that skill set that's rare, gives you a lot of power, right? That's pretty much it. If you have any questions, comments, or concerns, please feel free to drop a comment in the comment section. I read your comments. I leave a like or a heart, or I respond just to let you know. Sometimes I will put a heart, a impression or emoji on your comment. That means I read your comment. Or I will leave a heart and actually type a comment in there just to let you know I'm looking into it or I'm researching it. I don't really have the answers right away, but hopefully this is something that you will find useful, something that you will hope to teach others, and hopefully use it in your day-to-day job. So with that, thank you so much for watching. If you have any questions, comments, and concerns, please drop in the comment section. And don't forget to like and subscribe. I'll see you in another video. Thank you.